All right, let's take a look at this problem. This is chapter 2, problem 57, and this is an example of a problem that the College Board loves, and it's in a category called literal problems, where everything is expressed as a variable or a letter. So literal could be literal, and I did not like these when I was in physics the first time, but I've come to understand it, or come to appreciate them since then. All right, so here's our problem, and we need to draw a picture. We've got a very slippery slope, which means that its friction is 0 with an angle theta, and there's a block of ice, and it slides down, and it's at a height h, a vertical height h, and it goes down to the bottom of the ramp. And we want to know, it starts from rest, so V initial or V naught is equal to 0, and we want to know what V is at the bottom of the ramp. All right? And we need to find an expression for that. Okay, so we know that it goes a distance, and I'm going to call this distance D, right? That it slides, and that's H. We know it's accelerating. What do we know about this? Well, if there are no other forces, if there's no friction, and I often like to write that there is no friction on this plane. We haven't talked about friction, and so there isn't any yet in our world. If we know that on a ramp, the acceleration due to gravity on a ramp is equal to g sine theta. So that's what we know. We know V naught is 0. We know that delta x is d, and we know, and we want to find V final. All right. Now, let's see if we have an equation that will help us with this. Well, we don't have time, so how about how fast, no time? Let's try that one. V final squared is equal to V naught squared plus 2a delta x. Great. And so V final will be equal to this square root of 2a delta x. Well, that's fine, but we need to know it in terms of h and theta. And so let's plug in g sine theta for this and d for that. So V final equals square root of 2 times g sine theta, and delta x is d. But we don't really know d, but we do know that there's a trig function here that we can invoke. We have an opposite side and a hypotenuse. And so we could say sine of theta is equal to the opposite side, h, over d. So d equals h over sine theta. Okay, and so let's plug that in. We're still under the square root. 2g sine theta times h over sine theta. And the sine thetas cancel out, and this becomes the square root of 2gh. So the V final is equal to the square root of 2gh. Let me get that on the camera. There we go. So that's the problem. And then the second part of the problem asks you to verify that by putting in numbers. So I'll leave that to you to do.